Hey guys, we've been studying natural selection, and so I thought I would take a minute today in our learning block to go over kind of a new concept, or a concept that goes along with natural selection that I'm not sure is explained real well in the course. So we're going to talk about what happens to organisms when you apply different types of natural selection to them. And first of all, what you need to understand is that most organisms, when you have a polygenic trait like something that would produce a range of phenotypes like you see here with our moths, the white moths, the brown moths, and the black moths, these guys occur along a bell curve, and we learned that back when we did the polygenic trait lessons. So this is what a bell curve normally looks like. Now what's going to happen is we're going to apply natural selection in different ways to our population of moths that you see here. And what that's going to do is it's going to change the shape of our bell curve a little bit, and I want you to watch how we change that shape. So let's look at this scenario. My bell curve looks a little wonky, but you get the idea here. Let's imagine that this is the color of the background now. All right, so we had a population of moths that was living in a situation where all three of these coexisted together, the white, the brown, and the black, and then something happened to the environment, and now the background that all of these moths live in is black, okay? Obviously what's going to happen here is the numbers of the white moths are going to go down, right? The numbers of the brown moths are going to go down because neither of these is camouflaged against the black background, but our black moth population is going to actually rise as a result, right? Because now the black moths are camouflaged. So what happens is if we draw this on what happens to the population on a curve, what you'll notice is that these populations are down, but then the black moths rise in population. So what's happened here is our bell curve has actually shifted over. Remember, this black is the original bell curve, and the red is what the new bell curve is because our black moth population actually went up. This is called directional selection. Directional selection. Because the bell curve has moved over, it's shifted in one direction, right? The bell curve top was here, now the bell curve top is over here, so it's moved over. You can have directional selection that goes the other way too. I just happen to choose a black background. But if our background was white instead of black, you would expect then that the white moths would go up and everything else would go down. Okay, let's look at another scenario. Here we have, instead of a black background, now we've got this brown background. Still, your white moths, poor guys, their population is going to stay low because they're not camouflaged. But now our black moths are also not camouflaged, so their population is going to drop. The one that's going to be the most successful on this background is going to be our brown moths, and their numbers are going to increase even more, which means our bell curve is going to get higher. Okay, so our bell curve gets more exaggerated in this kind of selection. This is called stabilizing selection, stabilizing selection. So before we had directional selection where we moved the bell curve over. This time our bell curve is getting higher, it's getting taller, and your ends are dropping off more. So that's stabilizing selection. All right, last scenario here. So this time, imagine you have an area where you have some background that's white and some that's black. Okay, so maybe there's some white birch and some maybe some dirty birch trees, like in your peppered moth demos that you normally look at. In this situation, what's going to happen is on the black background, the black moths are going to increase in number. On the white background, finally, our poor little white moths will increase in number, and the only moth type that's not going to be camouflaged is this brown moth, so it's going to drop in number. And if you trace that, what you get is kind of a two-humped graph, right? So instead of having one curve like our black line, the original population, what you have now is a two-humped graph. You've got two selected for traits. This is known as disruptive selection, disruptive selection. So again, natural selection will act on the population differently depending on what the environment looks like, okay, and so you can get any of these scenarios happening. Again, if you go move the bell curve over to the right or to the left, that's directional selection. If your bell curve gets taller, it's stabilizing selection, and if your bell curve kind of inverts on itself and you get a two-humped graph, that's disruptive selection.